Happy birthday to me. Happy birthday to me. Happy birthday, Mr. C.S. Happy birthday to me. Happy birthday to me. Happy birthday to me. Happy birthday, Mr. C.S. Happy birthday to me. Hello there, Barrington. I bet some of you have been doing a lot of this lately. And it's really important, isn't it? Washing our hands during this crisis, we're told, is going to help us to stay healthy. So it is a really important thing. But for today's science, I wanted to look a little bit at the science of soap and of hand washing. And I've got a few experiments that you can try at home today in your kitchen. So to get started, we're going to need some dish soap, washing up liquid. We don't need loads of it. Some ground pepper. Hopefully white or black pepper will be absolutely fine. The idea is that it's in very, very small dusty particles. So if you've got anything in your cupboard that's a very, very fine dusty consistency, that will work fine. A couple of plates needed, and a piece of paper, and a glass with no designs or patterns on the outside so that you can see what's going on inside. As well as that, you're going to need some oil. Now, it doesn't matter which oil you use. It all should work the same. Vegetable oil, sunflower oil, or even olive oil. But don't tell your parents if you're using olive oil, because it's quite expensive. So I'm going to start with a little experiment to demonstrate that water is sticky. It's a really, really simple one, and it looks like this. I've got a plate and I've got a piece of paper. And I wanted just to do a quick experiment to prove that water has a stickiness to it. So the way I'm going to do this experiment is I'm going to tilt the plate and I'm going to press the piece of paper to the plate and just let go. And as you can see, this paper is dry. There's no stickiness at all, and the paper is free to fall off the plate. What I'm going to do now is I'm going to wet the paper with a drop or two of water. So I've got a little amount of water here, and I'm just going to dip my fingers in and just dab a couple of drops onto the plate like this, and I'm going to stick the paper onto the drops of water like that. Now what happens when I tilt the plate? Aha, the paper sticks. I can even turn the plate upside down. So this is a property of water that causes wet things to stick to other things. And that's an interesting quality. This is the reason why we use water to wash our hands with. Because the water is actually going to stick, or help to stick, to those particles of dirt and wash them away, leaving your hands clean, and all of the germs and dirt is going to go down the plug hole, down into the drain. So what I wanted to do is use this property to do an experiment. So I'm going to get a white coloured plate. White is important so that I can see what's going on. And onto the plate, I'm going to pour some water. I'm going to pour enough water to create a nice puddle in the middle of the plate. It's probably a good idea to do this near a sink. Now, on top of the water, I'm going to put some of my pepper. And because the pepper is in very, very fine particles, it's going to float on the surface of the water. You can put as much as you like on. There you go. Now what I'm going to do is I'm going to take a single drop of dish soap, and I'm going to put the smallest amount in the middle of my plate of water, and I want you to watch carefully what happens. So I'm not talking a big squirt here. You can see a tiny little drop about to come out. Here we go. Are you ready? Wow. Quite startling, isn't it? So what's going on here? Well, the dish soap is affecting the stickiness of the water, and it's pushing the surface tension of the water outwards away from the drop of soap. It's affecting the surface tension of the water, and it's actually causing the particles of pepper to clump together and stick together. And this is a good analogy for what is happening when you wash your hands. The water is going to provide the stickiness, and the soap is going to allow the particles of dirt to clump and stick together so that they can be washed away. Now, if you put some pepper in other parts of the plate, it won't have the same effect, which is interesting, I think. So that shows that whatever the single drop of soap has done, it's affected the whole surface of the water. And there's very little effect for adding any more soap. So a little soap goes a very long way when we're washing our hands. I want to do another experiment now to explain why the soap is so important and what the soap actually does to help us get our hands clean. So very, very carefully, I'm going to pour this one down the sink and we're going to do our next experiment. Now for this next experiment, I'm going to need a half-filled glass of water. And into that glass of water, I'm going to pour some oil or some fat, because we know that oil is a type of fat. I'm going to pour in a decent amount there. And you can immediately see what happens. I'm going to zoom you in a little bit closer here. The oil has formed a layer on top of the water. And this is because fats, or lipids, which is the scientific word, lipids don't mix with water. They form a separate layer. There'll always be a few little drops of oil, but as you watch carefully, you will see they actually get absorbed into the main layer and rejoin the group. So we have a water layer and an oil layer. Now here's quite a fun thing to do. Give it a stir and see what happens. So I'm just going to get a fork in here. I get a nice view. Get my fork in. Now have a look what happens. I'm going to take my fork out. And almost instantly, the oil is rising to the surface and it's forming that layer again. So no matter how hard I stir this oil and water, as soon as the stirring stops, the oil begins to separate from the water again. Quite amazing. I'm going to give that one more try, just to prove that it wasn't a fluke. And this time, I'm going to zoom in. Okay, I've come back after a few minutes, and as you can see, the oil has completely separated out again, and I'm left with my two layers. So what we're going to do now is we're going to see the effect that soap has on this lipid or this oil layer. And the reason why we're doing this is because the virus that causes COVID-19, the coronavirus, is surrounded by a layer of lipids. It's surrounded by what we call a capsid of lipids. So if we can find a chemical or some sort of substance that will damage or destroy a lipid layer, we've got something that is effective against a virus. And it could be any virus. It could be the virus that causes a common cold. It could be the virus that causes the flu. Or obviously what we're thinking of currently is the virus that causes COVID-19. So I'm going to add some soap now. Just a squirt of dish soap to my glass. Again, a little goes a long way. We don't need much. I'm just going to add a little bit of soap like that. Really, no more than the amount that you would use to wash your hands with. You'll notice nothing's happened yet, but let's give it some stirring action and see what happens. So I'm going to give it the same sort of stir as I gave it last time. Okay, let's have a look now and see what happens. Well, straight away I can see a difference. That layer is not forming. The oil is staying mixed up from top to bottom in this glass of water. I'm not getting the same level of lipid layer that I was before. And this is absolutely crucial. This is why we ask you to wash your hands with soap. Because what the soap is doing is it is damaging or destroying the lipid layer that surrounds viruses and other nasty bugs that can make you sick. So what's happening with this experiment? Well, let me show you. Okay, I'm going to draw a drop of oil. There's my drop of oil. And I'm going to draw a particle of dish soap. There's my particle of dish soap. So what soap does is it's got two ends. We've got one end here that is attracted to water. And we've got one end here that is attracted to oil or fat. We called those lipids earlier. So when the dish soap meets the drop of oil, which is what this is, you will see that the ends that are attracted to oil and fat will stick to the oil, and the ends that are attracted to water will poke out. And you will actually end up with many, many, many particles of our dish soap surrounding the drop of oil, like this, making a bubble, maybe even more dense than that. So we've got an oil droplet in the middle, surrounded by soap. And remember, this end of soap is attracted to water. So now the oil is surrounded by a bubble of chemicals which are now attracted to water at this end. So when we get some water droplets coming along, these ends of our soap will stick onto the water droplet and carry it away from your hand, carry it down the drain and away, leaving you with nice clean hands. So this is the importance of washing thoroughly with soap and water. The water is sticky, but it's not going to stick to the oil or the virus or any other bugs by itself. The soap acts as a bridge. The soap will stick to the oil or dirt on one side of its molecule, and it will stick to the water on the other side. So this allows the water to stick to the oil indirectly, with a molecule acting as a bridge. So there you have it, folks. Wash your hands with plenty of warm water and soap, and don't forget to sing happy birthday twice.